So today's talk, we're going to talk about packaging, and it's going to be in two phases. But first, who's this Phil guy in front of you? So I'm a third-generation packaging automation business owner. My grandfather started off with those Toledo dial scales that you see in the corner. And then over the last 50 years, through 3 generations, we got more into more advanced automation. But our core competency is still in scales and weights and measures and things like that. So I was kind of raised in the business, so I actually have 25 years experience in packaging automation, both on the equipment automation space, but we're also a pouch manufacturer, so flexible packaging and child-resistant technologies and things like that. On a personal note, it took about a decade, but I convinced my best friend to marry me, and then together we have 4 kids and 14 chickens. So today's kind of going to be like drinking from a fire hose, but it's going to be in like 2 sections. So the first section, we're going to talk about the container piece. So we'll still talk about glass jars and how to automate them and everything else. But the focus on the consumable side is also going to be more around pouches and child resistance and flexible packaging. The second piece will be more equipment and automation, and it'll be full line automation, right? So it's going to be not only how do you get the stuff in your package, but how do you make sure the weights are correct, there's no foreign material in it and things like that. So I've been in these seats a lot, and a lot of people dive into the details, but I think it's helpful to like zoom out and like, why the hell do we even need packaging, right? And so one of the coolest things about the cannabis space is the entrepreneurial spirit and all the cool things that get developed, and there's so much passion in the product development. And ideally, you don't need us, right? Ideally, you create your product and right there the consumer can have it. But unfortunately, you still have to get it to a dispensary and get it on a shelf somewhere. And so our goal in the packaging space is essentially to take whatever your creation is, and as you intend it to get to the consumer, it is just like that, right? And so it's about picking the proper packaging and making sure when you automate it, you're not degrading all this hard work that you guys put into your product. So on the first section, when we talk about containers, we're going to talk about pros and cons between flexible and rigid, the different pouch types and styles. We'll dig deep into printing and how that works and the different film technologies behind it. And a super often overlooked thing is actually sizing pouches for automation. And this is something we see a lot where people put a massive investment in pouches that weren't properly sized. And then you end up with millions of pouches that you can't actually use. And then a huge thing, obviously, we'll talk about child-resistant technology and closures and things to make sure that you're keeping kids, outside of your THC product. So let's talk about flexible versus rigid. So on the flexible space, you kind of end up with better printing and brand options. It's really, really, really hard to print a rigid container like a glass jar or a plastic jar, which is why you typically resort to labeling. The cool thing about pouches is you get a lot higher fidelity print. It's higher resolution. You can use a lot more colors. It's lower cost. It uses a lot less material. It's a lot more environmentally friendly, which towards the back end we'll talk more about sustainability and green and things like that. It's easier to carry and transport. You think about trying to fit, a jar or a plastic thing into your purse or a pouch or whatever. It's a lot easier to slide a pouch into your pocket than it is a large jar. Rigid, however, it does have a higher end appearance, especially with glass jars. We still see a lot of high-end cannabis flower in glass jars, and it makes sense because it gives that high-end appearance. This does, however, come at a higher cost. It typically requires labeling. It's really hard to directly print a glass jar. So not only do you have the cost of the jar or the container, but now you actually have the cost of wrapping some type of label around it. One thing rigid does really, really well compared to flexible, though, is it kind of protects from physical damage, right? Because it actually has essentially an exoskeleton around it. So there's 2 basic pouch types. There's a stand-up pouch. So this is the thing with the bottom gusset that stands up on its own. And then you have the flattened pillow pouch. So typically what we see, stand-up pouches on the flower space will be like your 8s to ounces stand-up pouches, a lot of edibles, things like that. That flat pillow pouch is really, really good for maybe grams, or on the edible space like single serve, like 1 or 2 gummies and things like that. It doesn't matter if you do the stand-up pouch or the flat. In terms of seal configurations, you can pretty much have whatever you want. And there's a ton of zipper technologies, tear notches, and everything else. And again, that's not tied to your pouch style. You can pretty much have that in anything. So there's two basic printing methods that we'll go over. One is traditional or analog printing, and another is digital printing, which is kind of like the latest and greatest, which in this space we steer more people towards digital. So to really understand traditional printing, even though it's been modernized, it helps to understand kind of the history of it. And so this guy, Gutenberg, in the 1440-ish developed the printing press. And essentially, it's the process of creating some kind of plate that you can slap ink on. And back in his day, it's any color you want as long as it's black. And then you transfer it to some substrate. Even though he's credited with it, I'm a little bit of a history buff. It actually goes back to the 800s in the Tang Dynasty. They were just hammering and chiseling this out. So conceptually, this is the same thing that we still do today with traditional printing. It's just a little bit higher speed, and we can use more colors. And so if you look at a traditional printing press, you're still etching something and applying ink to it. It's just a little bit more advanced. So if you look at a traditional printing press, essentially what you have is a series of ink baths and then a printing plate. So if you've ever bought any type of flexo or rotogravure printing, whether it's a label or a pouch or anything like that, and you see these one-time plate fees, that printing plate is essentially what you're purchasing, and you have to purchase one of these for every single color that you have. Then you have an impression roller on top, which is just going to apply pressure to whatever you're printing on. So in this case, it's film. So in flexible packaging, typically what you're printing is going to be clear. So in order to get color, you need to kind of like flood it with white. And wherever you don't put white is where you'll end up with like a window. So if you want to see into your product on that white plate, you just kind of etch an area out so you can see through it. But it's kind of rinse and repeat. So if you ever bought, your way overpriced cartridges for your at-home printer, you tend to buy like CMYK. It's the same thing in the industrial space. And so as you can see, it's like the combination of your cyan plate and your magenta plate and a yellow plate and your key plate, which is essentially black. By combining all of these, when you overlay them together, you get a full color image. So this is really just a more advanced version of what has been around since like the 800s. But the problem is every unique print, every SKU, you now have to purchase all of these printing plates for every single one. And these presses are massive. It'd be like from here to this wall. And someone has to go through and physically change these plates out, drain the ink baths and everything else. So anytime you change any print, you have all these plates, you have all this ink that you have to change out. And this is where digital came in and why it's like really been really good especially for industries like this. So in digital print, you still have the same process of laying down multiple colors, but instead of having these printing plates, you essentially have a digital print head. And so again, it's like an industrial version of like your HP printer at home. And so now these presses can actually change on the fly because you don't have these ink baths that you have to drain. You don't have these physical printing plates that need to be re-etched and changed out. And so this is why digital, it's really good if you have like a lot of SKUs or you have low minimums because you can change the press on the fly. There's actually no physical changeover. And they're physically small. Instead of being from here to the wall, it's probably about the size of this stage. So to really understand it, we can kind of look at a cost example. So say you want to print 10,000 bags and you have 2 SKUs, which 2 SKUs, it's basically, I don't know if everyone knows what a SKU is, but it's any type of unique print. If anything changes, you basically have another SKU. So say in the digital space at 10,000, 2 SKUs, it's a 50-cent bag. Traditional presses, because they're so huge and you have all these printing plates, you actually can't run this low of a volume. So in the traditional analog world, you actually don't have an option. At 50,000, 2 SKUs, your digital cost comes down now because, economies of scale, you're running more stuff, right? If you're kind of importing, you might have an option, but in general, this is still too low to do the traditional analog route. But now when you go higher volume, say 100,000 with 2 SKUs, again, your digital price drops. Your analog or traditional print is cheaper per bag, so you'll save 5 cents. But those printing plates now you have to buy. And in the digital space, you don't have to buy these. So now, for 2 SKUs on average, you'll drop about $4,500 on printing plates. And if you amortize this over your bag cost, now it's about the same. So in theory, your first order is the same as digital. And if artwork didn't change, now you have a cost savings. But as we all know, in cannabis, with law and everything else, regulation changes, forces, artwork changes. your marketing department forces artwork changes, right? So we tend to recommend, even at this point where after the first order it makes sense to go traditional, usually staying digital in the long run matters. And so if you go higher volume, 500,000, still 2 SKUs, this is where the analog route really starts to make sense, because now your per bag costs drop quite a bit, even with plates. But now, so you have that same quantity, but now you have 10 SKUs, right? So you're launching 10 flavors of gummies or flour and a lot of different strains. This is where digital comes. So even though at 500,000 you went from 2 SKUs to 10, the digital space, because you're not changing out printing plates, your cost stays the same, right, per bag. And then in the analog route, your per bag cost just increased, because now every time you change a SKU, someone's got to stop the press and change these printing plates out. But the huge thing here is now you just dropped 20 grand on printing plates for 10 SKUs, right? So now if you amortize that over the cost of the run, it's more money. And now if every single order you're having to rebuy all these printing plates, this is where digital makes sense. So this is mostly to encourage you to not always look at that per bag price, especially with traditional or analog printing, and kind of like zoom out and look at the whole picture. Because in general, digital, even if your per bag price is more, it tends to make more sense. So now we'll talk about film. So does everybody use or buy Mylar pouches for their flexible today? This is actually kind of like a misnomer. So Mylar, even though we associate it with the balloon and it's silver, Mylar film is actually not a great film for cannabis, at least standalone. So Mylar is actually a DuPont trademark, and it's just a clear low barrier film. It's on the outside of pretty much all the pouches that we buy. That silver high barrier thing that you see is actually a metallized layer. And it's that metallized layer that gives you your barrier. And so to look at this more in depth, we like to think of bags as being like this one layer of film, but it's actually usually 2 to 4 layers, often glued together. And each layer brings a unique attribute to the table, which is a cool thing that flexible packaging has. So typically, that PET layer on the outside, this is technically your Mylar, which you typically hear. But this layer alone actually does almost nothing for you. It's combining it with other layers that you actually get something out of it. So you bring some type of a barrier layer, like a metallized PET, and then this is where your high barrier comes from. There's also clear films that'll give you a high barrier that you can laminate in. Foil, which like the coffee guys use a lot, you can laminate in. It's a very good barrier. And then below that, those top 2 layers you actually can't heat seal, but they give you your barrier. So then you throw another layer of some heat sealable material. Polyethylene is the most common. If you see any acronym that ends in PE, it's just some variant of polyethylene, and that's essentially your heat sealable layer. And the thing to note is this is what makes up the most thickness of your pouch. So like if you look at a pouch spec and you see 3.5 mil, and you look at another pouch spec and it says 5 mil, you would think the thicker pouch actually has a better barrier, but it doesn't, because it's those top 2 layers actually gives you your barrier. The rest is basically just melty goo, so you can actually heat seal it. And so all they're doing is that inside layer, they're just making it thicker. And it does give you kind of that perception that it's a thicker and better pouch, but in reality, a 5 mil pouch and a 3 mil pouch with this exact same film structure, just a different sealant, will actually give you the same shelf life and everything else. It's more just, the way that it kind of feels in your hands. So what you'll see often in film specs is you'll basically see these layers just separated with a slash with some really confusing acronyms. And at the end, they'll tell you what the overall thickness is. You don't have to print the pouch, but if you do print the pouch, the ink that you see is actually protected. That's why you can never scratch it off. It's actually between that PET layer and whatever your barrier layer is. They call it like trap printing, so actually printing between 2 layers, and that's what protects your ink. So film barrier characteristics, there's 2 common acronyms that you'll see, OTR or WVTR, sometimes they call it MVTR, but it's basically your oxygen transfer rate and your moisture transfer rate. So again, we like to think of plastic bags as being like airtight, but if you've ever thrown your weed in a sandwich bag and noticed that you can smell through it, or if you put a mint or any spice, you notice you can smell through it, it's because most films are not airtight. Oxygen and moisture can constantly travel through them, and they do, and it's reported in some type of a rate. And so to understand this, it's helpful to understand how it's tested. And so this is kind of like a rudimentary graphic of how we test it. So you have a package, and then you have oxygen molecules on one side, shown in red. And then what you actually do is you put nitrogen molecules on another. And then there's a sensor, and that sensor is an O2 sensor, so it'll only detect oxygen. And then over time, it's going to detect the oxygen molecules that can pass through the package. And essentially what you'll see on a film spec is you'll see an OTR and MVTR, and it's basically measured in some area, which empirically is going to be like 100 square inch area per day. And you'll see the same thing with water, but instead of cc's, it's going to be grams. And the important thing to keep in mind if you only have one takeaway is you want these numbers to be as low as possible. So as close as you can get to zero is ideal. If you look at film specs for like foil, like they use in coffee, you'll see values really, really close to zero. Metallized packaging, or like the Mylar that they say a lot in cannabis, it's like fractions, right? It's like 0.1 or 0.2, and that's really what you want to be. So an often overlooked thing that we run into a lot is pouch sizing. And a lot of people put the cart before the horse in this spec, and that they get really, really excited about the brand and the marketing, and they go all in on graphics, and they get super excited, and they throw out the print, and they make 1 million pouches, and they throw it on their factory floor, and it's like, holy shit, it won't fit in the bag. Now what do we do, right? And so this is kind of what we recommend the steps to actually be. So working with your manufacturer, what you really want to do is just take a bunch of plain pouches and fill it with whatever your product is, whether it's flour or edibles or whatever. And you want to check what we call head space, which is basically just the empty space. So when you pack it all in there and you're sitting there holding the pouch, it's like how much space do you have between the product and the top? You don't want it filled up to the zipper. You definitely don't want it filled up to the top of the pouch. You need, some amount of space there. And then when you roughly figure out what your proportions are and everybody agrees, now you need to get your equipment manufacturer involved. And essentially what you want to do is what we call drop tests. And so this is something that you can do just by cardboard and duct taping funnels, or you get your equipment manufacturer involved and we'll help you. And we're basically going to take your pouches, and on a conference room table, we'll do some manual drop tests to make sure the product will actually flow through and fit into your pouch. If that works, now it's time to do a larger scale test. And so what we recommend is taking some type of a plain or clear pouch. And this is something that your pouch suppliers should be able to provide, and actually run it on the equipment. And so it's one thing to sit on a conference room table and you do it 3 times, like, oh shit, it works, we're good. But think about packing thousands per day, right? So if one messes up out of 20, that's a really, really high waste rate. And so what we want to see is testing on some type of automation where you can run hundreds, ideally thousands without any kind of mistake. And so it's important to do this before you commit to any type of larger production run. And then now after all of this is when we recommend you do what most people do first, which is now that you settled on your pouch size, now get the die lines and now put your artwork over it. And this doesn't mean you can't do really cool marketing 3D mock-ups ahead of time. It just means before you really finalize the artwork and get to the point that you're going to place a pouch order, you really want to go through steps 1 through 3 before you jump into step 4. So now we'll talk about child-resistant closures. So it used to be there was only 1 or 2 guys in town that did the child-resistant zippers, and now there's a boatload. But because of that, and there's so many and they come from all over the world now, you really, really want to vet and verify their certification. There's a lot of child-resistant zippers that aren't so child-resistant. And even if you have the best closure in the world, you really want to vet the full supply chain. So if you have a really, really good zipper, but you weld it to crappy film, or who's ever making your final pouch kind of lacks the QC standards, ultimately your entire package won't be child resistant. So it's kind of important, even if you have a certified zipper, to vet that whole supply chain. And an often overlooked thing, because we call it CR, child resistant, is everybody worries about making sure a child can't get into it, which I have 4 kids I appreciate, but seniors still have to be able to get into it, right? So if you make it so hard that a kid can't get into it, but a senior can't, and they'll get frustrated and cut it open, right? That's considered a failure. And even if you send your products to a CR lab, you can actually pass the child side of the test and fail the senior side, and then you get it sent back, and then you get to spend an extra 10, 15 grand to do another test. So it's just something to keep in mind. So once you have your child-resistant zipper, now you have to make sure you're welding it to the correct film, right? And so Kids are really, really resilient and dedicated, and they will bite and do whatever it takes to get into anything. So you need to make sure your film is puncture resistant. And if you've ever seen video from a CR test, you'll see kids biting and trying to get into stuff. My kids would do it too if I put a good enough candy inside, right? They'll dig their nails into the side of the pouch and try to tear it open, which means you need tear resistance. And then all of this, if you're working with the correct supplier, they know it's essentially choosing the correct films. And even at the molecular level, how you orient the same substrate actually matters. So you can actually have a film in bag 1 fail, use the exact same film in bag 2, but you orient it different and it'll pass. And so just making sure working with people that understands these idiosyncrasies to make sure you have a success. So now let's talk about green. You know, there's a lot of documentaries. This is starting to become a hot button topic these days. And so before we talk about what's new and what's coming, there's an enormous amount of inherent benefits if all you do is go flexible instead of, you know, a glass jar or a plastic container. And so flexible packaging inherently, there's a lot less fossil fuel usage, there's a lot less material, it ships flat, we use a lot less precious resources like water to make it, so inherently that, you know, it's a more green sustainable option compared to a lot of rigid counterparts. It ships flat, and so if you picture plastic or glass jars shipped to you, right, before you fill them, you're mostly shipping air because they ship empty to you, and they take up an enormous amount of space. And so typically 1 truckload of pouches, because they're compressed and they ship flat, it's about 15 to 25 truckloads of, you know, glass or plastic jars. So this inherently, there's a lot less fossil fuel consumption just by going flexible. As we saw before with all the different layers that we can glue together, you can create a lot of really, really cool barrier characteristics that you can't with rigid containers. And so this ends up creating a lot less waste. So there's a lot less food and things that end up in landfills. And so a lot more basically ends up being consumed, which is more green. But now what's next? And this is what you see a lot. You have recyclable, and you have compostable, and you have biodegradable. And my personal favorite is the bio-whack-a-wuttable, which is people just make up fucking terms to sound cool so they can sell it. And they will add bio or able to the end of anything to try to sell it, which leads us to greenwashing, which is starting to become more and more of a household term. But essentially, if you don't know greenwashing, it's basically the process of some company, usually a tricky marketing department, sorry for any marketing people here, conveying a false impression that, hey, this is good for the environment, we put bio in it, we love the earth, we hug trees, blah, 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 blah. But really, it's all bullshit, and the proof is in the pudding. Most of it actually doesn't do anything. And so there's this big myth around cannabis packaging. So there is a lot of green packaging that actually does work, but the problem with green cannabis packaging is you need really, really high barrier films, right? So you need to preserve your product, you can't smell through it, and all these things. And this is the tough challenge. So there's a lot of packaging that technically would be green, but you would never want to put your product into it because it wouldn't be preserved. So we've been working on this as a company for about 5 years, and we've tested a boatload of films and ran a lot of stuff through certs. In our eyes, recyclable so far shows the most promise. The infrastructure isn't there yet, right? And so the recycle centers can't quite handle it. Everybody's working on it, but so far you can actually get a fully recyclable high barrier package. Certified compostable, this is something to really keep your eye on. You will see high barrier packaging that actually has a compostable certification. You cannot put it in your at-home compost pile. You have to take it to an industrial compost center. And who has ever taken anything to an industrial compost center ever, right? We don't. But we think it's, you know, greener. And then we think that it's compostable, that if it ends up in a landfill, you know, it somehow will degrade faster, and it doesn't. It's gonna sit there just as long as any other package. So again, it's kind of like a greenwashing thing. They can get a compost, you know, certified package, but in reality, it doesn't actually disappear any faster. Biodegradable, again, you will see this in other industries that don't require high barrier packaging, but in the cannabis space where you need high barriers, it's not gonna work. So biodegradable means it's gonna disappear in the presence of light and moisture and air. So if you need a film that keeps out light and moisture and air, right, it's probably not gonna work. And when in doubt, just make up a name that starts in bio or ends in able, and people will fucking buy it, right? So what we're putting all of our investment in is Dow's Recycle Ready technology. And so it's comparable in functional performance and stiffness. So for us guys that actually have to make the pouches, we have to run these on these huge machines, right? And so we need a machine that, you know, the film, when it doesn't stretch too much, we can actually convert it into a pouch. And this recyclable ready technology has enough stiffness that you can actually make a pouch out of it. And it's extremely high barrier. Even the clear recyclable materials has the exact same barrier properties as what people call a Mylar pouch, which is the metallized stuff. So right now the infrastructure is a little bit lacking. So recycle centers do not like flexible packaging. The pouches clog up all the rollers. But just like if you buy plastic bags and you can go back to Mylar or Kroger and turn these in, anything with a Dow Recycle Ready logo is the same thing. So if you do go back to the grocery store and you return your plastic bags, you can actually take any packaging from your home from Dow Recycle Ready technology and they will recycle it for you. But curbside solutions are still being developed. There's some municipalities in California that are doing it. There's actually some really cool at-home plastic condensing modules where you can throw your recycle-ready plastics in and it'll kind of brick them out. And then by bricking them out, recycling centers can handle it. So this is something that's being worked on and will most likely come to fruition eventually. And so now I'd like to talk about the importance of getting cannabis pouches domestically. So just being transparent, we've been importing pouches for like 15 years. I'm not against it. It's a global economy, right? But it's very different if you're importing a pouch for like a granola or a tortilla chip, as opposed to something that's extremely high value and there's a huge importance to something like child resistance. So it has a much higher risk profile whenever you're importing. And if you subscribe to any type of lean manufacturing or just-in-time philosophy, you know, a lot of shit can happen in 10 to 20 weeks while you wait for pouches to come to you, right? And so it can be local regulatory changes, which means by the time those pouches get to you, something just changed and you can no longer use them. You know, it could be marketing, it could be a new product launch. And so it's just something to keep in mind that even though you might save a few cents a pouch, if they come to you and by the time you get them, they're not usable, right? Now you just kind of lost your ass. And then where are the final quality control checks being performed? So we talked about barrier and all these other things, and essentially, if you have a domestic partner that you can visit and check out their QC lab, right, now you feel good that whatever you're buying is what you thought you were buying. But now if you're importing, unless you're going over there and vetting and sending someone over after everything, you essentially need to drop about $250,000 on a QC lab to make sure what you're buying is actually what you see. And so what we've seen a lot on the equipment side when we ask for pouches is we'll get a certified Sierra pouch that we can actually tear in half, right? Or we'll get a Mylar pouch and we'll throw it in our test chamber and find that it's actually not high barrier metallized film. They just took clear film and they printed it silver, which means your product's gonna go rancid really, really fast, right? And so someone somewhere needs to essentially perform these QC checks if you're taking the risk of importing. So that was phase one. So now we're going to talk about the automation piece, which is how you get all this stuff in your package without using a boatload of people. So we're going to talk about weighing product versus counting it. And so typically flour and things like that, we weigh products like gummies and edibles, we do counting. There's two core different ways of weighing. There's an algorithm called combination weighing that we'll talk about. There's also something called linear net weighing that we'll talk about. We'll contrast the two different equipment types, flour versus edibles. And then we'll talk about gas flushing. You'll probably see the acronym MAP, or Modified Atmospheric Packaging, which is basically just putting nitrogen into a pouch to extend shelf life. We'll talk about printing and labeling, package inspection and QC to make sure we check for foreign material. We'll talk about scaling and right-sizing your automation. A lot of people that we see, we spend a lot of time downselling people because a lot of people want to automate to the hilt, but often that's a mistake. It sometimes makes sense to grow into it. And then we'll talk about footprint and utility requirements to make sure that whatever this investment you made, you actually have what you need in your facility to support it. So let's talk about weighing product versus counting product. So there's kind of two ways you can do optical or weight counting. So optical counting means you're just dropping product through some type of a sensor and you're counting it, right? Every time it blocks a beam, you know you dropped one. So optical counting requires some type of strict product orientation. So you either have to drop one at a time or you have to drop the single layer at a time. And when you think about products like gummies that want to stick, this can be a very difficult thing. Weight-based counting actually does not require all this strict orientation, but it just requires that your product has a consistent piece weight. In the THC space, natively, you guys have to have a consistent piece weight, right? So weight-based tends to work really well for you guys. It's just something to keep in mind. So counting by weight. So weight-based count systems, in this example, it can easily detect two pieces stuck together as two, because two pieces stuck together weigh as two. This will trick a lot of optical systems in that if you have two pieces stuck together, it will actually count them as one, which is kind of devastating if your 5 or 10 count ends up being 6 or 11. There are a lot of advanced optical systems. We actually have one in our booth that we're kind of releasing at this show that instead of using traditional sensors, it uses really, really high resolution, full color, redundant camera systems. And it can actually map the product in real time and detect anomalies. And so some of these systems can reject it and say, all I know is this isn't a single piece. It may not know that it's two. Some can actually count it as two. One cool thing that these systems have is they actually provide basic inspection functions. So if you're running all red gummies and you get a yellow or an orange, it can actually detect it and reject it. You can do multicolor variety packs that way. And then even foreign stuff that you just don't want in your package, anything in your plant, a nut, a bolt, a Band-Aid, any type of foreign material, it can actually detect it and reject it before it enters your pouch or your jar. So one thing we get a lot of questions on when you're looking at scale systems is scale resolution versus accuracy. And these specs are often misunderstood. So a lot of people will see a resolution spec and assume that that's your accuracy, which is actually kind of a misnomer. So scale resolution is basically the smallest increment of weight that can be detected. And what drives scale resolution, it's really on the electrical side. It's just the sensors that the manufacturer used and the electronics inside. And you'll see this expressed in some type of weight. So you'll see like a resolution is 0.01 grams. So a lot of people see resolution of 0.01 grams and like, sweet, this is my accuracy, but it's not. All it means is that's the smallest amount of weight that the system can detect. There's a lot more things that go into play in terms of overall accuracy. And so your final accuracy will never be good as your resolution. So I don't care what an equipment manufacturer says, if they're saying it's a 0.01 gram resolution and saying this is your accuracy, it's technically impossible. So accuracy, it's how close to reported weight is to whatever your verified weight is, right? So this is more a function of system design, what your product is, how it's sized, especially cannabis flowers, if you're pre-sizing it before you put it into the machine, and the environment, if there's like a lot of wind currents and things like that in your facility. So your accuracy will never exceed 5 to 10 times the resolution. So this is important to keep in mind. So if you want a 0.1 gram resolution, say in your flower packaging operation, your resolution needs to be another decimal digit out. So if you want a 0.01 gram accuracy, you need a resolution that's an entire decimal place out. And so to kind of support this and talk about two different weighing technologies at the same time, we're going to talk about linear net weighing versus combination weighing. So we build both of these, and the linear net weighers, they're small, they sit on a table, and so a lot of people that want to do, say, flower packaging with really, really low volumes get attracted to this really small system and say, hey, I want to use this for my flower packaging operation. The problem is you only have one scale bucket, so then if you have irregular sized product, it's very difficult to be accurate because everything that falls off into that scale bucket is going to be a different size, right? So you're at the mercy of whatever falls next. And this is where a combination weighing comes into play. So the way a combination weigher works is either you'll see them on an inline, or the units that we sell, they're in a circle, but they're dropping product into multiple scale buckets at the same time. And essentially there's an advanced computer algorithm that then figures out what combination gets you your correct rate. So in this side, if we look at the single bucket on a linear net weigher, as the product's falling in and we're accumulating our weight, right? It's all fun and games. We're trying to run 1/8 ounce, which is 3.5 grams. So now we're at 3.17 grams, but now we're at the mercy of whatever falls next, right? So if it's a smaller bud, we might hit 3.5, but if it's a huge nug, we could go over. So if we drop a larger nug in, now we're at 4.3 grams, and we're 0.8 grams over. So going back to the previous conversation about accuracy and resolution, this system has a 0.01 gram resolution, right? We're counting by 0.01 grams. But we're 0.8 of a gram over because the system design relative to the product that we're filling isn't going to give us the accuracy we want. And this is where combination weighing comes in. And so the way a combination weigher works is it kind of doesn't matter what falls into what bucket. In this case, we have 10. The software algorithm is actually going to look at it and say, okay, what combination out of all these weights is going to give me my 1/8 ounce or my 3.5 grams? And so it's going to find this bucket, and this bucket, and this bucket, and this bucket, and with their powers combined, it'll hit exactly 3.5 grams. So statistically, the way the math works out, on like a 10-head system, you have over 1,000 combinations. The units that we sell are 14 heads, which is over 16,000 combinations. So statistically, even if you have a really large variance in your product size, you will always be extremely accurate. And so this is why when you have large irregular shaped product, even though you want this really nice small linear net weigher system that fits on your table, you actually need this higher end technology to support this combination algorithm to give you what you ultimately want. So contrasting flower versus edible packaging. So a huge consideration when you're doing flower packaging is gentle handling, right? So the amount of time you spend growing and trimming and cultivating and preserving your trichomes, you don't want this whole process to go to shit in your packaging operation. So you really need something that doesn't have really long product drops and things like that. You need extremely high resolution scales, especially if you're selling by grams. You need to be several decimal points out. Combination weighing is pretty much the only way to go with flower packaging, like we saw on the last slide. And a huge thing is a flower scale really needs to be purpose-built. And so a mistake we see a lot of people making, and shame on the equipment companies for doing this, is they take a combination weigher designed for tortilla chips or granola or something like that, because these are the same types of systems that Frito-Lay and everybody else uses, and they take that exact same system and try to use it in cannabis flower. But instead of resolving hundredths of a gram, it's resolving tenths or whole grams, right? Because you're not filling 16 ounces of potato chips, and who cares if you give away a little bit, you got a very expensive, precious product, right? And so you really want to make sure when you're investing in something to automate cannabis flower that it was designed and built strictly for cannabis flower, because there's really nothing like it, right? You can't use an off-the-shelf food machine for cannabis flower because there isn't a direct correlation to a food product. On the edible side, a huge consideration is sticky products. Gummies are sticky, a lot of baked goods are sticky. You can count or use combination weighing. One of the cool things on the edible side, though, is because the edible side is essentially food, it's just injected with THC. You actually can use a lot of off-the-shelf food machines. The only thing to keep in mind is that your ideal accuracy is going to be more than your typical food application. So you just want to make sure with the equipment manufacturer they can actually hit your accuracy. So like gummies, for instance, in the vitamin world, all the time they don't care if they're over a couple of gummies, right? But in the THC space, that's a huge deal. So you just want to make sure that they can actually hit those accuracies. So now we'll talk about gas flushing. A lot of people think that putting nitrogen or gas into a pouch is actually what preserves the product inside of it. This is used a lot in cannabis flower. The nitrogen actually doesn't do anything. All it really does is it gets the oxygen out. So the air that we breathe is roughly 20% oxygen, and that's what degrades the product, right? So if you leave it out on your counter, it's exposed to 20% oxygen, and that's when it'll start to go stale. If you put it in a package, and somehow you can get that package to have less than 20% oxygen, ideally maybe 2-4%, that's what preserves your product. So all the nitrogen is, it's just an inert gas to kind of push the oxygen out. It theoretically could be anything, it's just most of our air is nitrogen, so it's a cheap gas, right? So by putting the nitrogen in, it gets the O2 out, and that's what preserves your product. This is ultimately just to extend shelf life. A huge thing to keep in mind is this has to be used in conjunction with a very high barrier pouch. So if you spend all this time and money flushing all the oxygen out of your pouch, and then you pick a really shitty barrier, all the oxygen just comes back in, right? So you flush it down to 2 to 4%, it sits there for a week, the oxygen goes back to the film, and you actually haven't really gained anything. Another cool thing you can do with this is you can actually blow it open just to protect the product. So we see this in potato chip bags all the time. When you get that chip bag that's blown open, it's not them ripping you off, filling it full of air. It's them trying to make sure you get more whole chips, and less crumbs in the bottom. And you can do the same thing in cannabis with the right mechanism. So now we'll talk about printing and labeling. There's 3 core technologies, inkjet, thermal transfer, and print and apply labeling. And this table kind of compares them. So inkjet, this is that really low resolution technology where if you look at a package in the grocery store and you can see all those tiny little ink dots on your best buy date, that's inkjet. So inkjet is really high speed, it's very, very low resolution. Thermal transfer, this is like Frito-Lay and everybody else, and then chip bags, what you'll see is it'll be kind of more solid ink, so it's a much higher resolution. And then print and apply labeling is literally printing information on a label, which in this space would be like your metric label, right? And then applying that to a package. And so the lower resolution technologies like inkjet give you higher speed. So your typical like Coke or beer bottling lines at 1,000 or 2,000 a minute, they're all running inkjets. But all they roughly want to let you know is that the product's going to be bad by this date, or give you some traceability information. Thermal transfer, you'll see, on like a lot of potato chip bags or like candy bars, and then print and apply labeling, you see a lot less in food, but in the cannabis space, this is something that's required mostly for compliance labeling. So inkjet, because it's really low resolution, it's better for really, really basic text. You don't really want to print a barcode. Again, if you can see all those individual ink droplets and one ink droplet gets misplaced, that barcode can't be read anymore. Thermal transfer and print and apply labeling, because you don't have the individual ink droplets, do a much better job for extended information like a metric label or readable barcodes. So the cool thing about inkjet is it can print on virtually anything, even eggs. Those little codes that you see on your eggs are actually done by inkjet. Thermal transfer, it can only print on any type of tension film. So you will never thermal transfer successfully onto like a jar or anything like that. And that's where print and apply labeling comes into. So if you print a label, you can buy a mechanism to stick that label on virtually anything. It can be a pouch, a jar, pretty much anything. So now we'll talk about the QC side at the end of your line. So we'll go over check weighing, metal detection, which is the older traditional method for looking at foreign material, X-ray machines, which is kind of the newer, more recommended way, and then seal testing, which we see lacks a lot in most facilities, but it's extremely important to make sure you actually have a hermetic seal in your package before you ship it. So a typical check weigher weighs in motion. So picture just a conveyor belt that's sitting on top of a scale, and as the product goes across, it's going to weigh it. This is designed just to eliminate under and overfilling and helps ensure legal compliance. So like the food guys mostly want to make sure they don't short people, but in the cannabis space, we're held to really, really tight plus and minus controls. And so the check weigher is kind of like your extra security to make sure that you're within compliance. It also facilitates better data collection and reporting. So if you want to tie anything on your line to an ERP system or any type of data collection, your check weigher is usually your best bet, because where it's positioned in your line, every package has to go through it. And if you combine barcode scanning with it, you can now correlate lot and serial numbers with individual package weights and get a lot better data collection than if you go somewhere else on your line. A huge thing to keep in mind in this space with glass jars is that if you were to sit there and weigh all your empty glass jars, you'll actually see a huge variance just in the glass jar weight. And that variance is going to be more than your desired accuracy for like cannabis flower. So if you're going to use a check weigher on a glass jar operation, you actually can't just use one check weigher. You actually need to weigh the jar when it's empty, fill it, and then weigh it again to counteract that tare weight deviation. And there's a few ways of doing that. You can just buy 2 traditional check weighers, or you can buy a purpose-built system that is just designed for glass jars. So metal detection, this is like your typical lower cost device to look for foreign contaminants. So it's going to detect any type of ferrous or metal contaminant in your product. Again, a typical one is just a conveyor belt, and you kind of flow through this U-shaped device, and it's just going to look for anything metal inside. So this is mostly for customer safety, to protect your brand, right? You don't want someone to open your gummies and there's a nut or a bolt in it. The downside is a super limited detection. So if you want to detect all the crazy things that can go wrong within your facility, you actually need to invest in everything being metal impregnated. And you can do this, right? So you can go to Uline and all those other places. Instead of in your first aid kit having normal Band-Aids, you actually have to buy metal impregnated Band-Aids. Any plastic parts, everything has to have metal in it, essentially, in your facility, if you want to be able to detect all these things in your facility. And this is where X-ray really comes into play. So X-ray, this is basically the same system, more or less, that you guys go through at the airport that inspects your bags. It's just extremely high speed, and it looks inside your packaging. And so they're really good at particle detection and identification. It can detect almost any foreign object that you don't want, and so you basically train it through the X-ray of what good product looks like, and if it detects something different size, different shape, different density, bones, rocks, stones, pretty much anything. It detects that anomaly and it'll reject. But it comes at a much higher price than metal detection. It is, however, quickly becoming a preferred method. And so a thing to keep in mind is you have that elevated initial price in X-ray, but especially today with social media, we all see the stories of somebody who finds something weird in their package and then it goes viral and how quickly that can destroy a brand. So having this on your floor can kind of protect all that ahead of time. So seal testing, this is something we highly recommend, and we actually see this the least in facilities. And essentially, it's not a safe assumption that your packages after they're sealed is a full hermetic seal. You should really spot check them throughout the day. And so there's a destructive test, it's a bubble emission test, and you basically throw it in this tank filled with water, and the tank just pulls a huge vacuum on it, right? So picture a pouch in it, you put it in this tank of water, you shut the door, it's gonna pull a huge vacuum and it's gonna blow open like a balloon. And what you'll find is it stresses the crap out of the package, and you might get just a massive failure like the package explodes. But usually if the package is gonna explode, you could also see that with a visual check because you'll see a weak seal. But the big thing that it picks up on is like what we call channel leakers. And so if you have a really tiny pinhole leak in a package, and it could just be like an artifact on the seal jaw or something that you're using, when you put it in this machine, you're gonna see tiny bubbles leaking out. And you would never ever be able to see this with a quick visual check, but the chamber's gonna pick up on it right away. And so what we typically recommend is you invest in one of these, they're like a few grand, and then every 5 minutes or 1 out of every 100 packages, you just throw it in this chamber, close the door, run it. And if you have an anomaly, now you can go back test your other packages, go check your packaging machine, check the operators, and solve it before you ship hundreds of thousands of products that technically aren't sealed. So now we'll talk about scaling automation. A lot of people want to start large with this big, fully automated beast, but oftentimes it makes sense to step into it in more of a modular fashion. So a huge thing to keep in mind is your batch and run size. So even if you're running thousands of packages a day, that justifies a higher speed system. If you're running really, really small batches and doing a lot of changeovers, you'll actually kind of lose your efficiencies just in cleaning the machine, changing over, et cetera, et cetera. So in flower packaging, if you're running, hundreds of pounds a day, but you only have half-pound batches, you're actually better off doing a lot less automation, because between those tiny half-pound batches, you have to stop, clean the whole machine, right? And that's hours and hours of work. So really looking at your batch size and how you can schedule is an important consideration, in addition with your overall production throughput. So oftentimes, instead of going fully automated, it makes sense to take a step back and do semi-automatic, where you're using a smaller machine with less changeover parts and less things to clean, and still keep that human element and just make the human essentially more efficient. So an often overlooked thing is like your footprint and your utility requirements. So a huge thing to check out of the gate is your physical space restrictions in your facility. And we find a lot of people think in 2 dimensions, and they're like, yeah, I have the width and the length to fit the machine. But packaging equipment grows vertically, and it grows vertically very, very quick. So a lot of facilities have like 8 and 12 foot ceilings. This will not fit most fully automated packaging machines. You really want to be 15 to 20 feet if you can. So if you're building out a new space, we recommend going as tall as you possibly can on your ceiling. Most facilities have electrical, but not always compressed air. And so not only do you need an air compressor, but this is not a compressor that you just buy from Home Depot. You really need a compressor designed to run automation. So it's designed to run continuously 24/7. It's also designed to remove the moisture out of the air. Natural compressed air has a lot of water in it. And if that water goes into your big, expensive packaging machine, it'll actually rust from the inside out and destroy your machine. So you want to make sure you invest in that. Electrical requirements, most facilities have what you need. It's just worth checking to make sure that you do have the high voltage. If you're buying a high voltage machine, just double check single versus 3-phase power. And a big thing we come across a lot, believe it or not, is door size. So we've gone to install a lot of machines where the space has 20-foot ceilings, tons of square footage, and they have like a little man door to get the machine in, and it won't fit, right? And so if you're building out a new space, you want huge, big bay doors whenever you can. We've seen a lot of creative solutions where they just cut and demo something on the spot just to get the machine in, right? So if you're building out a new space, in addition to ceiling height, we really recommend getting as big a doors as possible. And that is it. Does anybody have any questions? Yes, sir.
Is there a good application for the linear equipment in cannabis?
There is. So CBD, a no-brainer, CBD gummies. And then if you're doing like a THC infused product, as long as you're okay after you fill it, basically double checking or correcting everyone. So from like a cost standpoint, you know, you could get a gummy packaging system on like a linear net weigher that is maybe like 20 grand compared to 80 to 120 grand. And as long as you're okay kind of micro correcting everyone, then yeah, you can do a linear net weigher. Yep. Yes, ma'am.
That machine that you had a person on one side and a person on the other side, how much do those machines cost? Is that just an estimate?
Yep. Would this be like for flower or edibles?
For both.
For both, yeah. So edible machines are typically a little bit lower cost, so say like 80 to 90 grand. Flower machines are typically north of 100, 130 grand. Yep. Any other questions? Awesome. Thank you, guys. I'll be here. If you guys need anything, I'll also be in the Dura-Pack booth. Have a good one, guys.